Hello and welcome back to another video. In this one we're looking at section 4.4 on the discriminant. So the discriminant is going to be really important because it tells us when you're given a quadratic equation how many solutions you are going to be getting. So if you had, for instance, in this quadratic formula that we had written here, let's just say you simplified it down and you got to something like this at the end, just hypothetically. Okay, now this right here is going to pose a problem because if you try to take the square root of -9, you're going to get an error in your calculator because you can't take the square root of something negative. So if you get something negative in here, that's going to pose a problem and you can't actually get anything out of it. So when that happens, you're going to end up getting 0 solutions. Now if I were to replace that -9 with, say, a 0, the square root of 0 is just 0. And so you're going to get -5 plus or minus 0, which won't add anything, and then divided by 2. So I end up just getting one answer out of this. Another situation we could get is maybe inside that square root, you get, say, a 4 or some other positive number. So when I simplify this, I'll have -5 plus or minus the square root of 4, which is 2, and then divide that by 2. And then I end up getting 2 solutions because I have this plus or minus here. So if this is positive, you're going to get 2 solutions. If it was 0, you get 1 solution. And then if it was negative, you end up getting 0 solutions. So that's why that discriminant is going to be important. So again, it just says there the expression under the square root is going to be called the discriminant. So this right here, that is the discriminant. That's what determines the number of solutions. So b squared minus 4ac is the discriminant. So we're going to have those 3 situations that I just kind of categorized up top there. So the b squared minus 4ac could be greater than 0. So that just means that it's going to be something positive. And when that happens, we said there are going to be 2 distinct solutions, so 2 distinct real roots. So when you graph this one, you're going to have some type of graph that's going to look something like this. If you graph the quadratic equation, there's going to be 1 solution there and another solution there. So 2 different answers, 2 different roots, 2 different solutions. Now the second one we said is when it equaled 0. So if that happened, we said there was going to be 1 solution. And then a graph for something like this, if we took the equation and we graphed it, it would have to look something like this. It would come and touch perfectly once and then go back up. So there'd just be 1 point touching on the x-axis, 1 root, 1 solution. And then the very last one is where b squared minus 4ac is less than 0, which just means that it is negative. And for that, we said there were going to be no real roots. And then the graph for one of those would look something like this, where it's not going to touch the x-axis. So it's got to be all above and pointing up. Or again, for all of these, you could have had something where it was pointing down, but there's going to be no x-intercepts, no solutions. So moving on from there, next we're going to do some examples where we determine the nature of the roots. And determining the nature of the roots, what that means is that you are going to tell me how many solutions. You're not going to tell me what the answers are. You're only telling me how many solutions there are. So there can be 0, 1, or 2. So that's your answer. 0 solutions, 1 solution, or 2 solutions. So we got 3 of those we're going to look at. And then lastly, on this page, we got a question where we're going to solve this kind of word problem here. And then after that, we got one more where we got kind of a longer word problem. So back to the start here. Determine the nature of the roots. So we need to use the discriminant to figure out how many solutions we're going to get. So this is going to be our a, that's our b, and that's our c. So remember, it was b squared minus 4ac. So b squared is 3, so I got 3 squared minus 4 times a, which is a 2, times the c, which is -10. Okay, and then when I calculate that, you're going to get 89, and 89 is greater than 0. It's positive. So when that happened, we got 2 solutions, or 2 distinct real roots. So 2 solutions. For the next one, I'm going to label my A, my B, and my C. And if you wanted to try to do this one on your own, you could try it. So again, it's B squared, so that's minus 12 squared. You got to be careful of squaring the negative. Minus 4 times A. A is a 9, and then times by C, which is a 4. Okay, throw that in your calculator, and you end up getting 0. So that means we're only going to get 1 solution. Okay, so don't think 0 means 0 solutions. 0 means you're going to get 1 solution. Okay, and then with the last one, you're probably already kind of knowing what's going to happen with this one. So we got A, B, and C. So that's B squared minus 7 squared minus 4 times A, which is a 3, times by C, which is a 5. And when we calculate this one, as you might have guessed, you get something negative. So negative 11, that told us whenever we got anything negative, there was going to be no solutions or no distinct real roots. So no solutions. So again, determine the nature of the roots means tell me how many solutions, don't give me the solutions. So moving from that one, with this one, we're going to be solving, and we're actually going to solve it a number of ways. These are all of our options that we've learned so far. We're not going to do it with graphing because graphing is a little simpler. You can just use your calculator, but we are going to do the factoring, completing the square, and using the quadratic formula. So in this one, it says 2 positive integers with a difference of 6 and a product of 475. So I want to find what those 2 numbers are. So if my first number is, say, x, my next number, if they have a difference of 6, it's just going to be 6 more. So I could either have x plus 6, or you could even do x minus 6. That would be 6 less. Both of those would work. So x plus 6 or x minus 6. So it told me that they had a product of 475. So when I multiply these two things, I'm going to have x times x plus 6. Make sure you put the x plus 6 in brackets. That is going to give me 475. Okay, so I'm just going to distribute this into my brackets. So I'm going to have an x squared, and then I also have the x times the 6. So that is a 6x, and that equals 475. So what I'm going to do first, I'm going to do this by factoring. In order to factor, I got to move everything to the same side. So when that moves over, it's going to change sign, and then we have minus 475 on the right side now. So to factor this, we got to find a product of 475, and it has to have a sum of, that middle number there has to be a 6. Okay, and the 2 numbers that actually do that are a negative 19 and a positive 25. So I'm just going to write that here, negative 19 and a positive 25. And with this one, it just breaks apart into those numbers. So x minus 19 and x plus 25. And then don't forget equals 0, still an equation. So to solve this, we just take each of these and set these equal to 0. Some of you might be able to just look at it and kind of know the solutions. So you're going to get x equals 19. And then from this one, if I set it equal to 0 and then subtracted 25 from both sides, you'll get negative 25. So those are our 2 answers. So that was our factoring method. I'm just going to put that up top. And then I'm just going to slide this all out of the way to the left here. The next way I'm going to do this one is I'm going to use completing the square. So for completing the square, what I'm going to do is I'm going to start with this line that we had right here. It's going to save me a little bit of time. So we had x squared plus 6x minus 475 equaled 0. So what we did, we took this middle number here, 6, we divided that by 2, and then we squared it, and we're going to get 9. Okay, so now that I know that number, that's the number I'm going to add and subtract down below here. So I got plus 9, subtract 9, and then minus 475 equals 0. So this first three terms here, that is going to be a perfect square trinomial. I can factor that. The x comes down, that middle sign comes down, and then I take the 6 down. But when I do that, I divide by 2. So I'm going to get 3, and then I throw that in brackets and put a square. And then these two terms I can put together. So minus 9 and minus 475, that's going to give me minus 484. And then we got our equals 0. Okay, so to solve this, first move the 484 to the other side, or add 484 to both sides. So I got x plus 3 squared equals 484. Then I got to get rid of the squares, so we take square root of both sides. Square and square root cancel out. So we got x plus 3 equals, and then the square root of 484 is equal to 22. And remember, that is plus or minus. And then last thing, we just got to subtract 3 from both sides so that those 3's cancel out. And so I get x is equal to positive minus 22, subtract 3. And that's going to give me two answers. So if I take positive 22 and then I minus 3, I'm going to get 19. And then if I take negative 22 and I subtract 3, I'm going to get negative 25. And notice those are the same answers as what we got using the factoring method. So the last way I'm going to do this one now is just using the quadratic formula. So again, I'm going to start off by using kind of this line here just to save me some work. So I know that 1 is a, b is positive 6, and c is that negative 475. So remember our quadratic formula, it goes minus b, so minus 6, plus or minus, and then we got our big square root, and then inside we had b squared, so that's 6 squared, minus 4 times a, which is a 1, and then times by c, which is negative 475. And then just make sure, if this line wasn't long enough, make sure you always extend it over everything in the radical there. And then all of that was being divided by 2 times a, so that's 2 times a 1. So simplifying this, in front I got minus 6 and then plus or minus. Inside the square root, you're going to get 1,936, so 1936 in the square root, all being divided by 2 times 1 is just 2. And then we can simplify that square root, so got minus 6 plus or minus. The square root of 1,936 is 44. Again, all being divided by 2. And then we're going to get two answers from this. So we're first going to do the minus 1. So it's going to be minus 6 minus 44. That's minus 50. And then divide by 2. You'll get negative 25. And then if I do the positive 1, that is going to be negative 6 plus 44, so that's going to give me 38, and then divide that by 2, I get 19. Again, the exact same two answers as what we had in the other two. Now with all of these answers that we've gotten here, the green one, the blue one, and the red one, they were all the same, but they are not actually our final answer quite yet. What we need to do is we need to take those numbers and we need to put them into these two expressions that we had at the very beginning. And recall that the numbers that we had, they had to be positive integers. So the one answer that we already got of negative 25, I know that that can't be actually a final answer because it is not positive. So that's actually extraneous. So what we want to pick is the 19. So x is going to equal 19. That's one of our answers. And then the other number was just x plus 6, so it's going to be 19 plus 6, and so we get 25. So these are our two answers, 19 and 25. What we had down below here, this helped us get to our final answer. but it wasn't the actual final answer. Now, a lot of the time what's going to happen is what you get here is basically going to be the two numbers. It's just one of them is going to have the sign incorrect. So make sure you just throw it back into those first two expressions you made and double check your answer. Okay, so you should be able to solve it using any of those three ways. And of course the graphing one we didn't do, but that one should be easier. Last example here now. So it says a picture measures 30 centimeters by 21 centimeters. So we already got the diagram of a picture 21 by 30. It says you crop the picture by removing strips of the same width from the top and one side. So I can see they've cut off a strip here. It's got the same width on both of these, and I did it from the top and then just one of the sides. It says that this reduces the area to 40% of the original area, and then it wants us to determine the width of the removed strips. So let's say that these removed strips were of width x. So if I know that that is of length x, if I wanted to find, say, this section right here, I know all the way across was 21, and then if I remove it back x amount, that's going to be 21 minus x. Same kind of idea going this way. The whole thing was 30, but then I took off x, so that's 30 minus x. So now I know the length and the width of this kind of smaller rectangle. And just to remind you again, area is length times width. So if I wanted to find the area of that smaller rectangle, it would be 21 minus x times 30 minus x. Okay, now that area, it has to be equal to, it said 40% of the original area. So the original area was 30 by 21, but it's only going to be 40% of that. So 40%, we're going to times by 40%, and 40% is just 0.4, 40 out of 100. So now I got my quadratic equation set up, I can start to simplify and move everything all onto one side. So I'm going to FOIL this all out. I'm going to have a negative x times a negative x. That's going to be positive x squared. I'm going to have negative x times 30. That's negative 30x. Okay, and then I have 21 times negative x. That's negative 21x. And then 21 times 30. That is going to equal 630. And then on the other side, we had 30 times 21 times 0.4. And that equals 252. So now that I have that, I just want to move everything all on the same side. So subtract 252 from both sides. That cancels out. Subtract 252 here. So I got x squared. And then these two I can put together. So that's going to give me negative 51x. And then I'm going to have plus. And I'll put these two terms together. And when I do that, I get 378. And then don't forget to put equals 0. Can't forget that it's still an equation. So again, to solve this, we could use any of the methods that we looked at on the previous page. I'm going to use factoring. So I got to have a product of 378 and a sum of negative 51. Now these numbers are quite difficult, so if you wanted to choose another method, you could, but in this case, the two numbers that are going to do that are going to be a negative 9 and a negative 42. So our brackets split up. We got x minus 9 and x minus 42 equals 0. And then we just take each of those brackets, set them equal to 0. And again, some of you guys might be able to just do this without. So you're going to get x equals 9, and then taking this one, setting it equal to 0, add 42 to both sides, you just get 42. Or you can just picture putting in that number. If you put in a 42 right there, 42 minus 42, that would give you 0. So you know it's going to work. So those are our two solutions for that one. X equals 9 and x equals 42. Now of these two answers, right, because this was an applied question, we got to think about which one of these actually works. So let's think about our diagram here. So if this x, let's first look at 42. If this was 42, Could you have a length of 21 and then you took away 42 from it? You couldn't. That wouldn't make any sense because you don't even have 42, so you can't take away 42. So this one doesn't make sense. We're going to have to cross that out and say it's extraneous. The second one, though, when x is 9, you could have this length being 21 and then you take away 9 from it. Same with the 30. If this is 30, you could take away 9 from it as well. So 9 works, 9 is okay, but the 42 is extraneous. So very last thing here now I'm just going to put our textbook questions down here at the bottom.